All right, in this lesson, we're going to talk about how to solve quadratic equations using the quadratic formula, and then we're going to talk about how the discriminant helps us classify solutions. Okay, and so the general form of a quadratic equation, it's going to have an x squared term followed by the x term followed by a constant term equal to 0. You know an equation's quadratic because you have an x squared term. If you just have an x, that means it's linear. And so in order to solve a quadratic equation, we use the quadratic formula. There's other methods, but quadratic formula will always work. And so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and this expression under the radical actually has a special name. It's called the discriminant. Okay, and so based on what value we get under the radical, that's going to tell us what our solutions look like. If your discriminant is positive, you're going to have a real solution. So in the case where it's positive, you can take the square root of positive, you're going to get a real number. Okay, in the case that it is a perfect square, you're going to get really nice solutions. Those are called rational numbers. If it's not a perfect square, you're going to have a square root involved in your final answer, and those are called irrational numbers. So some examples of rational numbers: 1/2, or even like -3. They can be whole numbers. They can be decimals, but they're going to be nice decimals. You can have 1/3. And so any number that can be written as a fraction or whole number is considered rational, whereas your irrational numbers are going to have square roots that can't be written as decimals. And so square root of 2, square root of 3, you can have negative square root of 7. And so all of these would be really ugly decimals that don't repeat, have no pattern, and they can't be written as fractions. Okay, if your discriminant is negative, that means you're going to have an imaginary part to your solution. So technically, these solutions are called complex, not just imaginary. They have an imaginary component, but they're complex numbers. And so that's when I shows up. And so some imaginary numbers would be like 2i, or even square root of 7i. You can have negative 2i square root of 3. Any part where I shows up, it's going to be imaginary. And then remember, complex numbers have a real part as well, which is what your solutions are going to look like. So like 2 plus 3i, or even 3 minus 2 square roots, or 2i square roots of 7. So anywhere I is, whether there's a square root or not, that's considered a complex number. And so for your perfect squares, it's going to be a good idea to have your perfect squares memorized. And so 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, at least up to 12 squared should be good. The last case we haven't talked about yet is when your discriminant is 0. And that's actually a very special case. If your discriminant is ever 0, you're only going to have one solution, and it's going to be real and it's going to be rational, but you're just going to have one solution. Okay, and so just kind of classifying these, our perfect squares here are 49 and 4. And so that case, we're going to have two real rational. So think of rational as nice. Two real rationals. These negatives, whether they're perfect squares or not, we don't care. They're going to be two complex solutions because of the negative under the radical. And then 15 and 20, those are positive, but they're not perfect squares. So we're going to have two real, but they're going to be irrational. So in this case, you're going to have a square root in your final answer. And in the case of the complex solutions, you're going to have I in your final answer. Okay, and so part of using the quadratic formula is we have to simplify some pretty ugly expressions. And so just starting with this first one, I see a negative under the radical, so we know that means we need to take an I out. So take an I outside, and then we can view it as a positive square root of 12. Okay, and then from there, we can simplify the square root of 12, because 12 is just 4 times 3. So that means we can take a 2 outside the radical, put it in front of the I, and then a 3 would stay behind. Now treat this I and this square root of 3 kind of like it's a variable. He can't interact with anybody else, but these numbers here, this -4 and 2, can be divided by this 2, and we need to do that. And so -4 divided by 2 is 2. 2 divided by 2 is just 1, so we'll leave it invisible for our final answer. So remember, we're getting 2 solutions out of this. And so one solution would be the minus I square root of 3. And then the other solution would be -2 plus the I squared of 3. Okay, over here, 49 is a perfect square, so we can simplify that to just a 7, no square root. And so when the square root goes away, you're going to have 2 rational solutions, and you need to break them into their cases. And so one case is the 3 plus 7 over 4. The other case is the 3 minus 7 over 4, which simplifies to 10 over 4, which is 5 over 2. And in this case, we get -4 over 4, which is just -1. So our 2 rational solutions here would be -1 and 5 over 2. Okay, and so we're ready to use the quadratic formula, and we're going to identify the discriminant along the way. So here we have ax squared plus bx equals 0, and so we know a is 1, our b value is 8, and our c value is -16. And so x equals plus -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and so our b value goes in the first blanks. Our a value goes in the next blank, top and bottom, and then our c value goes at the very end. Okay, and so now we're ready to just number crunch this. And so -8 plus or minus square root, 8 squared is 64. -4 times -16 is positive 64. And then 2 times 1 is just 2. And so simplifying further, 64 plus 64 is 128. And so I'm going to stop here and identify the discriminant. Remember, it's the expression under the radical. And so our discriminant is 128. That is not a perfect square. So we know we're going to have real solutions. We're going to have 2 real solutions. They're just going to be irrational. Okay, and so if we keep going, we can find out what they are. And so 128, we can rewrite that as 64 times 2. And so that means we can take an 8 outside of the radical and leave a 2 behind. And then remember that square root of 2 cannot interact with any other number. So he's going to stay exactly like he is, but we do need to simplify -8 and 8 over 2. And so our final answer would be -4 plus or minus 4 with the square root of 2. And so our two real irrational solutions are -4 plus 4 square roots of 2 and -4 minus 4 square roots of 2. Okay, I want to skip to number 3. The first thing we have to do is make sure this 12 is on the other side to be our C value. We need this equal to 0. Okay, and so here our A value is 1, our B value is -7, our C value is 12. And so getting our setup, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so our b value goes in the first two blanks. Our a value goes in the next blank, top and bottom. And then our c value goes at the very end. And so now we can simplify. -7 is just 7. -7 squared is 49. 4 times 1 times 12 is 48. And then 2 times 1 is 2. So that gives us 7 plus or minus square root of 1 over 2. And so I'm going to pause and highlight the discriminant. Our discriminant came out to 1, which is a perfect square. And so we know we're going to have two real rational solutions. They're going to be nice numbers. Okay, and so simplifying further, we can figure out what they are. Square root of 1 is just 1, so the radical goes away. And then we can break it into 7 plus 1 over 2, 7 minus 1 over 2, which simplifies to 8 over 2, which is 4, and then 6 over 2, which is 3. So our two real rational solutions are 3 and 4. Okay, I want to skip to the last one. And so here we're set up so our A value is 1, our B value is 2, and our C value is 2. And so getting our setup, -b plus or minus the square root of b squared minus 4ac all over 2a. And so our b value goes in the first two blanks. Our a value goes in the next blank, top and bottom. And then our c value goes in the last blank. Okay, and so to number crunch this, we have a -2 plus or minus square root of 2 squared is 4, and then 4 times 1 times 2 is 8. 2 times 1 is 2. And so simplifying this further, 4 minus 8 is -4. And so here our discriminant is negative. It's -4. So even though it's a perfect square, we're going to have complex solutions because we know I is going to show up. And so we know we need to take an I out. And then we know square root of 4 is just 2. So the radical will go away, but these are still complex numbers because of the I. Okay, and just like the other expressions, that I is kind of like a variable. You don't want him to interact with anybody else, but we do need to divide -2 by 2 and the 2 by 2. And so this would simplify all the way to -1 plus or minus 1 I. And so our two complex solutions would be -1 plus I and -1 minus I. Okay, and so I'm going to post the key for the 4, 5, and 6 that I skipped. So try to go through this yourself and see if you can get the right answers.